Okay.
All right. Welcome to the May co-working hour. This morning we have the great pleasure of having Alan O'Cash teach us something about Magic Castle and doing HPC in the cloud. Alan, please take it away.
Yeah, so today I'll talk about Magic Castle. So it's a tool for using cloud-based resources mostly for training purposes, but the clusters that are created in the cloud, they can be quite capable. So you can include support for fast interconnects and GPUs and things like that. So they can actually be quite useful beyond the training area, also potentially for research and things like that. So the presentation, so I'm going to split it between kind of the presentation and show and tell. And this presentation, I didn't create it, right? So the main author, the creator, the lead developer of Magic Castle is someone called Felix-Antoine Fortin. He's in Canada. He's in Laval, the University of Laval. And this presentation I'm going to give, he was the one who created it back for the 60 EasyBuild user meeting. So that was just a couple of months ago. So let me go over here. So why did they create this tool? So basically, it comes back to this education and training. He's part of an organization called Compute Canada, who I believe are actually changing their name this year. But they are an organization that covers all of the HPC collaboration of HPC facilities in Canada, and they hold a lot of workshops, so about 150 a year. Most of these workshops do require their HPC environment, right? So it's about teaching people how to use this HPC stuff for the most part, and the software that they have in there. So they need this environment, but to provide access to these clusters, of course, the people who use them need an account, and the account creation process can usually take a couple of days. So it adds overhead to this process that they wanted to avoid. So they were wondering, is it possible to replicate their HPC environment for training in something that removes some of this overhead? And that's where Magic Castle came in. So it's an open source project. You can find it on GitHub, and I'll show you I'll give the link later on, or I think it's already been distributed as well. So you can find it already in the emails that's been sent around about this talk. It replicates a Compute Canada cluster in any major cloud provider, and also it's pretty easy to extend it to other cloud providers. So there I think there's 4 major cloud providers that are provided with the distributions, but you could, if you wanted to, extend it for use with other providers. Use 2 main tools, one for the infrastructure, so that's Terraform, and one to configure that infrastructure, and that's Puppet. So basically, we create different kinds of instances, so different kinds of servers. So we have the management nodes, we have some login nodes that people actually use to get onto the system, and the compute nodes, right? So same as most systems. You also need volumes, so you need a place to store data. You need a network between these things, and you need some restrictions on access to that network, so network ACLs as well. Ideally, you also want certificates, you want DNS records, you also want to configure passwords for user accounts, things like this. And all of this can be done via input parameters to Magic Castle. So the 2 big tools inside are Terraform and Puppet. Terraform is the tool that's directly connected to the infrastructure, right? So that's the tool for building, changing, and versioning the infrastructure. It's described just by a high-level configuration file, so just a fairly straightforward syntax in a configuration file, and we'll see that in detail in the next couple of slides, and also in the hands-on, or not really hands-on, but show and tell. These resources are set up by a simple configuration file. For Puppet, it's actually the thing that manages how everything is configured in the infrastructure. So that's used to deploy things, configure the servers, manage them. And it has different kinds of configurations for each type of host. So we have those 3 types, right? We have the management, the login, and the compute nodes. The nice thing about using Puppet is that it's it's continuously checking that you have the right environment, right? So something like Ansible is a bit different in the sense that it kind of runs once and doesn't actually check the environment later on. So you might manually change that and it won't revert to a previous state. That's not true with Puppet. So it's like it avoids this need for, doesn't avoid the need, but it helps you if you don't have a system administrator. It will get you back to a particular state. And that's the useful thing about Puppet. There are other.
Oh wait, sorry. I was gonna pop in and mention that we're recording, but I see Benson has vanished. So.
Oh, okay.
Sorry. Carry on.
If I see him come in again, I'll just say it quickly.
All right. Thanks.
There are other types of HPC cluster projects out there. So there's vendor-specific ones like AWS Parallel Cluster, and there's Cluster in the Cloud, which works on a couple of different providers, and that's Ansible based. There's Elastic Cluster as well that works on a couple of providers. There's Slurm on Global Platform, NVIDIA Depop, Stack HPC. So there are a few, and maybe there's even more than this. I don't know. But you can see that there's different ways of, there's different tools out there that could do similar jobs. The founding guidelines in Magic Castle are maybe not the same as the other ones. So the idea here is that there's no custom command line interface. So Terraform, the actual tool Terraform, that's how you interact with Magic Castle. How the configuration is done is with Puppet, and that's to encourage the reuse of modules that they already have inside Compute Canada, right? So that means that you can reuse a lot of the things that exist in the Compute Canada infrastructure. You can reuse them here, so without doing something special. The other thing that's maybe a little bit special about this is that SE Linux is enforced on Magic Castle. So you get good secure. Well, you get SE Linux, right, which is not that usual to have that fully enforced because it's difficult to do properly, but that is enforced in Magic Castle. And then you maintain, well, the idea is that you would have user documentation and lots of it. I think the documentation is pretty good. Of course, there's always scope for improvements when it comes to documentation. So what does a release look like? It says here that the latest release is 9.2. I should have updated this slide because that's not true. There was a release yesterday and that was already 9. I think that's 9.11.2. So I found a little bug yesterday, and they made a new. And Felix-Antoine made a new release last night. So I think that's 9.11.2. So that's from yesterday. But it's basically the release is composed of information for different providers. So you have different releases or a different tarball based on which provider you have. That's just to make it easy for people to use. So you can have, right now there's actually 5 providers that are shipped, right? So there's AWS, Azure, GCP, OpenStack, and OVH. And then that's inside these are, well, this one is a file and this one is a folder, okay? So the provider is a folder. It has some files that are probably common to that a good few of them are common across the different providers. But basically, the main file that anybody who uses the release of Magic Castle will work with is this main.tf. TF is the Terraform file extension. And so basically, you typically don't necessarily, especially if you're only starting out with using Magic Castle, you wouldn't really touch underneath the provider folder. The only thing you would really interact with is the main.tf folder, and that's the file, and that's what we're going to look at today. So we're going to talk about the infrastructure, and basically, first we'll go through what the architecture looks like. So we'll look at what the infrastructure itself looks like. And so this picture gives you the full overview of how things look. So basically, you have this security group, and everything happens within the security group. What's exposed to the outside world is and the users are up here on the top, right? So they are connecting via the internet. And what's exposed is HTTPS, SSH, and potentially Globus as well. So people can access things through HTTPS, which would be Jupyter Hub, and then SSH as well. And then inside here, then we have the different types of things. So we have the login node, which we'll look at in detail in a second, the management node, and then the different worker nodes. And then they're connected by a network. The system logging is all passed back to the management node. There's which also is the home of the different file directories. or the different file systems. So you have home, project, and scratch that are the common file systems, and they're NFS exported to everybody, right? So to the login nodes and the compute nodes. So let's look a little bit in detail about the different types of nodes. So we've got the login nodes, and we have different services running on here. So we have Apache running, which is giving us access to Jupyter Hub. And we have SSH running, that's also running fail to ban. So it kind of is pretty strong at banning people pretty quickly if they try and do naughty things. That gives you some security. Or if they fail with their passwords, I think it's 3 times in an hour or something like that, they get banned for some period of time. Sometimes that can be a bit of a headache, but there's 2 access methods, so there's always usually a way to get in. Now, Globus, I don't really use much myself, so maybe somebody else knows more about that. Then the other 2 services is Puppet to keep the configuration of the node to create and use the configuration of the node, and Console as well, which we'll come to a little bit to talk about what that purpose is. For the management nodes, there are a lot more services running here. So this is the one that does our authentication as well. So if we use free IPA is used in here for the authentication, and that is connected to something called Moki, which you can use for web-based to create a web-based tool that will allow you to create accounts and approve accounts and allow users to interact with their accounts and upload SSH keys and things like that. So that's all web-based. You have the system logs tool to collect those. You have Slurm, you have Puppet, and also the Puppet server. So the server that all the other node types interact with to get information about what their configuration should be. And then some databases, Squid Proxy, which is needed for the software systems. I'll come to talk about a little bit more about that in a while. Then you have Console as well, which I'll also come to a little bit. I'm not an expert on Console, but I think we get the idea of what it's for in a minute. And then, as I said, we have these NFS exports of the different file systems, right? So home, project, and scratch. These are NFS right now, but there is in the pipeline the idea of using different types of file systems. So I think there's already support for something else, but I can't remember the name of that file system right now. CFFS.
Just want to jump in here and let Benson know that we're recording.
Yep.
Okay, thanks.
So on the compute node side, much more simplified. There's not too many services running here. The idea being that you're supposed to do computation on them. So we just have the Puppet running with Console as well, and then we have Slurm running, and also this Jupyter Hub single user. So the way Jupyter Hub works is that you use your browser to log into the Jupyter Hub service, and then when you run a Jupyter Notebook, what actually happens is you get a job on the system, and you'll actually run on one of the compute nodes, and you will have access to that. So the main interface is this particular file, main.tf, so this Terraform file. It has 4 sections. It has the cloud provider section, so something specific to the cloud provider. It has customizations that you can give for the infrastructure. So how many nodes do you want? How many login nodes do you want? What kind of features should they have? This is all possible to provide. You want some cloud provider. There might be some specific things that you would need for particular cloud providers. So for example, you can tag your nodes on AWS. You can tag your nodes to use EFA, which is the fast network that's available on AWS. So these kinds of things are possible. To do that, you need to provide an availability zone, so that they are actually, to make sure that they are physically close to each other, your different servers, right? So these are something that's specific to AWS. So there are a couple of things like this for different providers. And then there's DNS configuration as well. So this is optional thing, but it means it gives you a defined place where you can find a cluster. And we'll see an example of that. And then you have the provider. So as I mentioned before, there are 4 or 5 different providers that you can use. We're going to look at the AWS one today. In terms of the customization that you can do, you can give your cluster a particular name. The one we'll use today is hpc-carpentry. you can provide a domain, but if you can provide a domain, you can give a particular image. I use this image because we're using AWS today, and this is the Rocky 8 image for the zone that I want to use, which is EU Central 1. So that's a Rocky 8 image that's available in that zone. We would create 10 users, and then I would provide my public key so that we can, that's like effectively to put a key into the kind of admin account so that I can easily log onto the system. That could be provided via file or via string. So we'll do it via string today. And then you define the instances that you want. So what type of, what does the structure of my cluster look like? So you have a management node. You can define what type that is. So that depends on what's available in the provider. So if you've used AWS before, these things might be a little bit familiar to you. This is a particular type of node that's available on AWS. And you can say how many of those that you want and give some tags. So how are they configured? So this is configured. It's not surprising, right? This MGMT management is configured as an MGMT type, and also has Puppet, and also is the host of the NFS. So you can do these with tags. And the login node is configured as a login node. It has public, so has a public IP, and it also has some proxy stuff as well. I'm not exactly sure what the proxy thing does, but that's also there. On the node side, this is just configured as a node, but there are additional things that you could provide here. So for example, what's supported in AWS is that you can use spot nodes. So you can use spot pricing, which means it's significantly cheaper, usually significantly cheaper for you. So that's an additional tag you could provide here. You could also provide the EFA tag, which would give you EFA capable nodes. That would require some additional stuff as well. And also you need to ensure that the type of node that you ask for is capable of providing EFA. So there are some additional things you would need to know, but there's documentation on what's required there somewhere else. As regards to storage, right now I think there's NFS, and I believe that CFFS is supported now, but I have never tried it actually myself. I've only used NFS so far. And then you just decide the size. So these are in gigabytes. So you can say the home directory is 100 gigabytes, and the project and Scratch are only 50. But of course, you can configure these to whatever you want to use. Some cloud provider specific stuff. So for OpenStack, for example, you might want to give the list of floating IPs that you have available to you. You may want to configure the specific floating IP the IP that you want to use. For Google GPUs, you need something special to attach GPUs. I've never used that myself. And then this idea of regions, right? So different providers have this idea of regions as well, and you need to provide that in a particular way. As regards to DNS, so this allows you to set up a proper URL for access to your system. There are different values that you give here. Most of these you don't change. Usually the only one that you will touch is the email. You need to provide the email that's reflected on your DNS provider. So Cloudflare is the one we'll use today. And then when all of that is configured, you can actually just apply that plan and you'll see what happens. And now we're actually going to do it, right? So we're going to start from scratch and do this. So let me get out of here for now. And let's go here. So so that you guys can actually see everything that I'm doing and maybe look back at it in the future, I'm going to use shell share, so you can see exactly what I'm doing in my shell. So here's a URL where you should be able to get everything that's in my shell.
For visibility, can you increase the size of your terminal?
Yep.
Thanks.
You can go to that URL and then you should be able to follow things from there as well. So you can increase it there too. Let me do that. Oops. Yeah. Is that better? Is that enough?
Yep, that's great. Thank you.
Yeah. Okay. So let me just clear this. Has anyone tried that link just to make sure it looks okay now? So I don't know.
Yep, it works.
Yep. Okay, so I just cleared this. So the first thing I want to do is pull down the release of Magic Castle. So like I said, there was a release yesterday, 15 hours ago, which is 11.9.2, yeah. So we're going to take this one and let's grab that. So we'll grab that release. We're unpack it. 11.9.2. Okay, so this is a release, and this has that something like the structure. Actually, he needs to update that slide so it doesn't look exactly like what he had in the slides. But this is basically it, and the file that we're interested in is the main.tf file. What I'll do now is I'll edit it in VI here, and then I'll cat it at the end so you can see exactly the difference. Actually, no, what I'll do is I'll do a git init here. Git add dot. Okay, so now I can just git diff at the end and see the changes that I make to the file. So let's have a look at the main.tf file. So here's what the file looks like. We'll go through it piece by piece. What I'm going to use for Terraform, I'm going to use the Terraform cloud a little bit. So let me just show you what the Terraform cloud is. So basically, I have an organization called Easy. I have a Terraform cloud account. And basically, there's an organization in here called Easy. And inside that, then you can have workspaces. The workspace that I'm going to use today is the AWS one, which I have. To configure that, so in general with Terraform and with things like this, I need access to credentials, right? So I need to be able to configure things on AWS and also on Cloudflare, right? Flare, because I want to do DNS stuff. So I do that via variables. And so here, we can see the different variables that I have. These are environment variables, okay? So the different variables that I have set for this workspace. So I've got my AWS key. Oh, where did it go? My AWS key, access. Why does it keep doing that? My AWS access key, the secret of that key is down further, and then 4 different entries related to Cloudflare, okay? So that I can remotely configure the Cloudflare stuff. Okay, so right now there's you can see that it tells me in here about what the resources are and what the outputs from the runs of Terraform have been. You don't need to use Terraform Cloud; it's not essential, but I have found it useful personally. So I like it because if for some reason you actually accidentally delete a directory where you had configured resources, I can go back here and create actions, in particular the destroy action, to be able to destroy all the resources. Without needing access to that directory anymore. So I have found that useful. Okay, so up here, the first thing it's saying is that it's a required version of Terraform. This is one place where I'm going to make some changes. So rather than, and it's not the carpentry style, I'm not going to do it bit by bit, but I'm just going to copy in the information. So let's see. So basically, I'm going to tell it to use a remote backend, which means tell it to use the Terraform cloud. The organization that I'm going to connect to is Easy, and the workspace is AWS, right? So that's the one that we've seen here. Okay, so Easy, workspace, AWS. So that's going to connect here, and then I come on to the AWS module, right? So the provider module, and I want to change these things. So it's going to use the Puppet. You can tell it which version of the Puppet configuration you want to use. You can use a specific commit or a release, because this is the 11.9.2 release of Magic Castle. Then we're going to use the same release of the Puppet Magic Castle as well. And the cluster name, we could give that anything we want right now. So in my slides, I agreed that I would call it hpc-carpentry. And then the domain that I actually control is called, or one of the domains I control is called learnhpc.eu. What it's saying here is, so the default it's shipped is this Rocky Linux in the CA Central, right? So Canada Central Zone. I'm not going to use that. I'm going to use the one that I have. That's for the zone that I want to use. So here, that is this image. Okay, and now we're already onto the instances that I want to use. T3 large, medium, and medium. I'm okay with those. I don't want to make any necessary changes, but rather than have one node, I'll have 2 instead. That's interesting, just for fun. The home directory, projects in Scratch, these are quite small listed here. I could make them bigger, but for the purposes of this tutorial, it doesn't really matter, because I'm going to destroy this cluster at the end anyway. The public keys is expecting it to pull it as a file directly from where from my home folder, but I don't want to do that. I'm actually going to provide it as a string, because on the cloud environment, that's the way you have to do it. So just provide it as a string. Come on. Okay, so that's the public. That's my public key for me, and the number of users that I want to create. Okay, I will create 10. You can set a guest password here as well, which we won't do, so that it'll just create something in random and tell us what that guest password is at the end. There's some specifics here for AWS. It's telling me the region, right? I don't want CA Central 1. I want EU Central 1. The other change, there's a couple more changes that I'm going to make here. So by default in Magic Castle, you're going to get Compute Canada software environment. I contribute to a different kind of software environment, so I want to use that one instead. So that's the software stack, and that's equal to, I want to use EC, which is the one that I contribute to, so I know a lot better. And there's one other thing that I need to do, and because this is another speciality, because I'm in a public cloud environment, I want to generate an SSH key. True, right? So it'll generate a remote SSH key to use and put on the nodes that they can move between, so they can upload information there. Small t. Okay, I think. Let me see. I think that's almost everything I need to do. Just checking my notes here. So I do want to use the DNS. So I do have DNS available to me. I'll put my credentials there, and these will work. I need to change the email address here to the one my own. It's actually my personal email address. Okay, that's the only change I need to make there as regards this. You can also use Google Cloud as your DNS if you want, and we will also output the host names. So this is optional output that you can print to the screen when it's finished. So we'll do. Oh, sorry. And that is the end of that file. I'm going to save this and then do a git diff, just so you can see the differences that I made here. So that will be in the shell share. You should be able to see that now in shell share. So if you want to look over at the changes that I've made here, you can do that. At this point now, then we should be able to do Terraform apply. So it will complain actually first, I suspect. Yeah, because I haven't done it. You need to use another command first, which is Terraform init, just to initialize the Terraform environment. And so we do that. And this shouldn't take too long. It'll pull in all the different modules that we need to use for Magic Castle. So these are different things related to AWS, related to Cloudflare, related to getting certificates. And I think that's probably all. And now we can do the Terraform apply. It will take a little bit of time. So here we can see, if we actually go back to the login, we can see to our AWS, we can see something should be happening here. And so look, it runs. Yeah, you can see I've got something that was triggered via CLI that's coming from here. So it started to plan something. You could look at the output here, but actually it's coming into my terminal as well. So it's being streamed directly to my terminal. It's telling me that 51 things are going to change, and there was nothing there before, so we're going to be added. There was nothing there before, so they're going to be created from scratch. And then we just basically tell it to do this. Yes, we want to create this. And then it'll start telling me information about what it's actually doing, right? So basically about what it's trying to create, where, and the status of that, right? So in a second, we should get some output here. You can see the same output. You can see that the apply is now running here, and it's starting to give information here, which is actually streamed. It's actually coming to our terminal here as well. So you can see it's, for example, it's trying to create, things are going to move fast now here. So it's trying to create the volumes. It's creating our certificates. It's creating our networking, our subnets, our gateways. It's creating our security groups. And then eventually we'll see it's creating, it's creating the NICs for our different nodes. And then it's going to create the instances themselves, right? So the login nodes. And then we attach the NICs to the nodes. It's still creating a certificate here. Hopefully that will come. Yeah, that's good. Okay, so now it's creating the Cloudflare records. That shouldn't take long. So it's also configuring all my DNS. So sometimes things can take a while, sometimes they don't. It depends. So I see. This is, of course, this is the problem with doing something live. Usually the Cloudflare stuff does not take a long time. That should have been done already. These things can't, the timeout on these is something like 4 minutes. But it shouldn't. Oh, it might be the certificate. If the certificate doesn't come, I see the certificate is still being created. So if the certificate doesn't come, then I will have a problem.
We got lots of time on our slot.
Yeah. So sometimes what can happen is with the Acme certificate, if you make too many requests for certificates, you get blocked. And so I was, of course, trying things out between yesterday and today. So if my certificate doesn't come, then the Cloudflare records will also not happen.
So could you use another certificate? I mean, not live now, but I mean, in general, you could use. So you said you were using what your certificate provider was?
It's what's it called? The Let's Encrypt. Let's Encrypt.
Oh, okay, okay.
Yeah. So I think that's my only problem right now is the certificate. That's not working. Yeah, timeout. I got a timeout on that. So let me maybe I made a mistake. Let me try something different. So I can change. I'm going to dynamically change the name of the cluster now. Instead, we're going to call it Rhubarb. Our cluster is now called Rhubarb. And this will trigger a different certificate creation. Hopefully this should work.
So the apply is smart enough to only stand up things that are different now, or did it?
Yeah, it will recognize what. So I mean that's, and it's never perfect, unfortunately. But the dependencies between things are somehow known. It's part of what inside Magic Castle, right? So it will recognize that lots of things I don't need to change, but some things I do. And the certificate is one of those.
Yeah.
And so now we'll see that lots of things will remain the same, but some host names will change now, and then the certificates will change. It'll tell me it'll destroy 14 things and it'll create 12 new ones.
Okay. That's actually really cool. That's having this hiccup and seeing it do the diffs is maybe pretty high value, actually.
Yeah.
That's something I hadn't appreciated or even really thought about.
So we can see the deployment of higher data is just, it'll change all the Cloudflare records. That's what most of the changes are, right? Oh, it actually changes a few things. Changes for some reason it's connected to this NFS. I don't know why that is, but.
Is it NFS v4 with auth?
I really don't know, to be honest. Not sure. You'd have to look inside Puppet to figure that out. Or you probably, I mean, if you know enough to ask that question, you could probably, once we get onto a node, check it out pretty quickly to answer yourself. Okay, so here we see in this case the certificate was created. So it's already completed that part. So now we should get to the end, and this should work. So unfortunately on AWS, it can take some time to destroy nodes. So it can take up to like 2 minutes or something like that for a node to be destroyed. So, but I think we should wait for it. I think it's worth waiting. Because I just want to show one thing before I move on a little bit with the presentation, and then we come back to this.
So you said you could use, so supposing you don't have a Cloudflare account or other DNS creds, it looks like you said there's a Google thing you can do.
Well, so if you don't control a domain, you don't need to use one. You can just use SSH, right? So in the end, you'll be given a fixed IP, an IP address, and you can connect to that IP address.
Okay.
So you don't have to have a domain to use this. But it just does mean that you get the additional services. So things like Jupyter Hub and things like that. So things that require Apache and certificates and everything, they will work for you. Whereas without the domain, attached domain, you don't get these things. Or maybe there's a way of doing it, but I don't know what it is. I've never done it without it.
I actually have, I do control a domain, but I've only ever done the DNS thing once, and it was very manual. I don't know what the API is.
I wouldn't do it. I wouldn't do it manually. So I've never done that,
obviously.
but I know it's quite a few entries, right? So it's quite a few changes. So it's better to let Terraform manage this, because you don't need to know what for one, which is a positive, and then destroying it later is a lot easier, right? So it's
the thing I did, the one time I actually needed to add a name for a public facing thing, the API that I used is you go to the provider website, and they have a tool where it actually pops up the zone file, which you edit in the browser, and then push go. Luckily, I know how to edit a zone file, so
yeah. So I mean,
presumably there are other ways to do it. I mean, I was kind of in a hurry, and as soon as I got to something I recognized, I did it. I didn't research it, but
yeah. So I don't know those kind of things, so that would be a big hassle for me. So that's why this is so easy, right? I mean, basically you put that's why it's actually explicitly why I put the domain I did control within Cloudflare,
right?
Because then I get these API tokens, and then Terraform does everything for me. I don't need to do anything. So unfortunately we're still destroying here, and it's taking a long time. It will eventually work, but it seems to be taking a very long time.
So I guess I have so when we do configuration management, or when I selected a configuration management tool, I picked Ansible, and one of the reasons I did was that it doesn't require any daemons on the clients. I think Puppet does, right? But
yes,
I guess
but
I guess your Rocky image has that already, or your deployment script does it, or something.
Yeah, exactly. So part of the initialization script that gets everything that every node runs is to install Puppet.
Okay.
So that's done through
Cloud Init, or
yeah.
Okay.
And so basically, there's a place inside Magic Castle where there's a set of commands that it will run, there is conditionals in there, so you can put things that are conditional on your node type. So for example, on the worker, on the compute nodes, you wouldn't have Puppet server, but on the management node you would. So basically, it's just things like that. But more or less, what happens? The basic thing that happens is you upgrade the system. So you upgrade the packages that are available on the system. That's the first thing that happens, and then you install Puppet, or Puppet and potentially Puppet server, and then Puppet kicks in and does everything else at that point. So I think maybe console as well. Maybe console comes in at the early stage, but I think no. I think it's just Puppet. So you just upgrade the system, and then Puppet starts. Okay, so we have one of the destructions, and we have another destruction happened now. So we've got 2 out of the 4. Hopefully the others will come along very quickly. Yeah, this is one of them, just happens, right, that it takes a while. Okay, now everything else is being created. Our new instances are being created.
Do you need to have the AWS CLI tools, or are they provided from the?
No, they're part of. It's like it's part of Terraform. So there's
Okay.
they have like packages inside for different providers. So AWS and Azure. So they just exist. The only thing that's defined in Magic Castle is the version of those, and
Okay.
which one you want to use. So, for example, the change that was made yesterday, and the reason that he had to push out a bug release with a bug fix release was because of the version of the AWS package that we use. It actually didn't support spot instances anymore, or not, or there was a bug in the implementation, right? So we had to revert back to an older version of that package. So it's just there's something. I guess it's not used by many people, but there was an issue there. So this we should be deploying the certificates. Okay, so we're getting close to the end.
Are there? This is a bit of a sidebar, but do you know if there are good SE Linux resources?
No, so I don't know a lot about this stuff at all. So Felix-Antoine is, because he's had to keep trying to enforce this. It's difficult, right? It's
Yeah.
difficult
So
to
this
get
is
it
the
with
thing
Slurm.
is, so we have a standing issue for NIST internal systems that we're supposed to do, I guess, either or both of AppArmor or SE Linux.
Mhm.
And I've tried to do SE Linux, and I don't, like, I'm missing some conceptual piece, right? Like, it's got
Yeah.
zones and ACLs and things, and what I'm interested in is files and directories, and it seems like there's an impedance mismatch between what you specify and what you want. But maybe I'm being naive. I don't know. And people do it. It's obvious cost.
But I know that it's hard, right? And it keeps it's complicated, and trying to get it to work together with Slurm, because of how Slurm works and everything,
Right.
has issues, right? And so I think it's better now. I think in recent releases of Slurm, things have improved, something like that. But I've never done it myself, right? I only know from the kind of traffic in the Magic Castle repo about SE Linux, about the kinds of things that you run into.
So there's some traffic in the chat too from Benson. He says you can get temporary free domains from various providers. He mentions freenom.com.
Oh, that's good.
Or from Red Hat, I guess.
But see, you need to actually control the domain. So not just a subdomain, but the actual domain. I think that's required. Yeah, so I'm not sure. But you need to have, but basically you need the API, right? You need to make sure that the Cloudflare API would work for you, for example. So I don't know if that would.
Now I'm curious about my provider's API. Let me go look.
Yeah. Okay, so things have worked, right? This is it. These are the host names that we have, right? So the different things. So we've got Moki, IPA. These won't actually be work until Puppet is finished doing its job. But this is what they will be. We can already log into the system, right? So we can do CentOS. CentOS is the admin user on these systems, right? So I can already log in here, and it knows my key. I remember I put my public key in here. So it knows those. It knows it already. It's in my cache, right? So it just let me log straight in. So now I'm on the system, and we can see what's going on. Let's have a look at top. It's just doing stuff right now. It's updating the kernel. I'm guessing from that command that's working there. We're on the login node now. It's not configured yet. It's still only. Let's have a look at. Let's see what this is. We can have a look and see what it's doing. Right. So right now it's updating system. It's updating the kernel, things like that. I'll take this.
So Slurm is not right. So if you did sinfo, you just get command not found.
Yeah. Right now you will get nothing. Right.
Okay.
So we can try it, but it's not ready. Yeah. So this will come a lot later. Once Puppet starts doing its business. But we can look into. So you would like to be able to do this to log into the management node. This also won't work yet until Puppet has done its job. But there is an alternative name. So what is available already is a route to the same node, which is just Puppet, right? So if you just say SSH Puppet, this will work because I've key forwarding. So I have an SSH config that will automatically do key forwarding for anything on the domain learnhpc.eu. So this key forwarding will work. and I can get directly onto the management node. We can use the same command as before. This is the one that I use. You can use lots of different things to see what's happening. The same situation. It's updating the kernel right now, so it's slowly getting into the process of updating the system, and eventually it will start using Puppet. So while it started, yeah.
So when you SSH to Puppet, that wasn't a public IP, right? That was 10.something.something.
Yeah, that's internal, right? It's inside the
Okay.
internal network. Yeah.
Oh, I see. So it's because it's your AWS account and because.
So we can, ping Puppet. So that's it. So what I'm doing here is I'm inside the internal network once I'm in login 1.
Oh, I see. You're on
is,
login.
right?
I'm sorry. Yeah. All right. I failed to grasp that you were already on login 1.
Okay. And so, yeah, basically, and then from here, I just jump onto the management node, and this would always, so SSH Puppet should always work. And eventually SSH MGMT1 will also work, but only after Puppet has done its business. So let me go back to the presentation here and just talk while this is going on, while it's configuring things, and Puppet will start to work. I'll do a little bit more. And so basically there's information in these YAML files about how things are configured. You typically don't need to touch them, but maybe at some point, once you've used Magic Castle a little bit, you might get interested in things working in a slightly different way. And then at this point is the point where you might start editing things like this. But basically, how does Puppet work, right? So first thing that does is TensorFlow injects some data, so the Terraform data, so information about the system in general, and that's used, right? So the first thing that's happening, the thing that's going on right now is this Yum upgrade. We're upgrading the systems, and then on the management node, the next thing that will happen is formatting the data volumes, and then we get the Puppet installations on everybody. Also, Puppet server will be installed on management 1. At that point, then Puppet will run for the server, and then they'll wait. So these guys will wait until till the server is properly finished before then they will contact and look for information so that they can configure themselves. The hosting. So what happens is that a number of Puppet modules. So there's a Git clone of a particular repository, which contains all the configuration for Puppet. That's only done on the management node, so that's cloned locally. These modules are installed, everything's rebooted, and then everybody will synchronize themselves with these Puppet modules, and that's how we get all our services. So I think that might be coming up. Yeah. So basically, management 1 is he's in charge of everything. Then, and basically we have the login node and all the different workers, right? And he's telling everyone how they should configure themselves. Console. I don't know much about console. I don't know much more than what's on this slide. But basically, it's a way of getting some information, so it can query. The node gets some information, and effectively, that's done just so we can configure Slurm properly. So we have an idea of like what's the architecture of the node, how much RAM does it have, how many CPUs does it have, a GPU, and to communicate the information back so that Slurm can use that information. We can also use it. It's also used to get the architecture of the nodes as well, to know exactly what architecture they are. This is important. The architecture is important for Compute Canada, not so important for EC. So it's a little bit related to the software stack. And because of the way console does things, then we can communicate information back to Slurm, and then it will do the registration and then the weights as well. So the weight computations for how things should be done. GPU support is there already. So if there are no GPUs available, NVIDIA GPUs available on the nodes, they can be used. Other GPUs have not been looked into yet, but that is probably something that will happen eventually. On the software side,
oh, just real quick for Anajiat's benefit, Anajiat, we're recording, just so you know.
On the software side, the operating system, you have a choice, but basically it's all Red Hat based. So you can have RHEL 7 based systems, so like CentOS 7, or you can use Alma Linux or Rocky Linux. It kind of depends on what's available, but all those are supported. I'm not sure if there's more beyond those supported, but I don't think so. I think it's just Rel 7, Rel 8 systems, but maybe not all. Sometimes they require a little bit of tweaking to be supported.
But yeah, so on that, I guess so the image is base install. It's not.
Yep, it's a
Okay.
basic.
Because obviously,
image.
I mean, you could have an AWS image with Slurm on it already. But
yeah, you could do that. Yeah, but that's not the approach here. So
okay.
so the approach is
yeah.
Yeah. So in our case, I mean, funny enough, so suppose on Azure, you might be interested in a custom image because of, say, for example, something like the InfiniBand card support. So you could already have an image that has that InfiniBand card support baked inside already. I have done that in the past, but I also know way that you could also. I mean, in the ideal case, you wouldn't do that. You would actually bake that support into Magic Castle itself. So figure out how to configure that so it works. That would be the preferred way. But there's using an existing image is a way around that. That's sure. So it does come with batteries included. So it comes with free IPA, which is like a way to manage accounts on the systems, which does support connecting back into LDAP systems as well. NFS comes with Slurm, has a Globus endpoint. I've never used Globus, so I don't even know what that really means. Jupyter Hub, LMOD, so to manage modules, the No VNC, the desktop solution, that works with the Compute Canada software stack, but not with the Easy software stack because we haven't looked into supporting that properly yet. Singularity is also on there as well, so you can run containers on the system as well. The software stack, so both of the solutions use CERN VMFS, so it's like a kind of a cloud-based distributed file system, and basically all of the software is available on this file system, and then you only pull down the files that you actually need at runtime. So when you do a modular avail, you get a big list of available software, but in fact, nothing is on the system until you try and start to use something. What that means in real life is that things can be slow when you first run something, but then the second time it'll have been cached at various levels. So also with the Squid proxy, so things will be fast once you've used something once, but the first time you may find it to be a bit slow, and perhaps we'll have time to see that. So the Compute Canada one has about 600 different applications, and they're all compiled with EasyBuild, as is the stuff that's in Easy as well. And so Easy has been available for, I don't know, I think it's a year and a half or something like that now. Users can self-register. So basically, if they go to the Jupyter Hub page, there's the create account, which will pass them back to Moki. And there they can register for an account that would have to be then be approved by an admin in the IPA portal, which looks like this. So basically, when someone self-registers, it will appear as an entry in here, but then you actually have to activate that account before it will work for somebody. And at that point, then they can use Moki to also upload, for example, an SSH key, something like that. So there's Jupyter Hub as well. It's a pretty good environment because it includes a special plugin for Jupyter called Jupyter LMOD, which allows you to dynamically load modules in your Jupyter Hub environment. So it means you have access to all the software dynamically in Jupyter Hub, and that's very interesting. I don't think we'll have time to look at that today, but it does work. The way it works is that when you log into Jupyter Hub, you actually end up you spawn directly onto the cluster. So you'll actually be on a worker node. You can define the amount of time, the amount of memory, even the amount of cores that you want, but you are restricted at maximum to a single node. You can also request a GPU if they are available, and that's possible too. And then, before we move on to MC Hub, maybe I'll just go look back and see how are we doing over here. So it kicked me off because at various points it's doing things related to SSH and shutting down and rebooting the machine and things like that.
Yeah,
so
I was going to say, if it did a kernel, it should reboot, right? So
yeah, and so here we are on the login node. We still don't have sinfo. That still doesn't exist. So let's have a look at Puppet. See how we're doing here. Let's have a look at the var. So we can see the Puppet is doing things right now. It's gone on to free IPA, so it's doing that part of things. I think that comes before Slurm. Yeah, pretty sure it comes before Slurm. So there's probably still, so it takes about 20 minutes before a cluster will be up, and that somewhat relates to how powerful the node is as well, obviously, because it's doing certain work. These ones are not very powerful, so this might take a little bit longer, but 20 minutes is usually the time. Yeah, it's still doing various things. We'll come back and look at it again in a minute. So let me go back to my presentation again. So MC Hub. So what I've shown you so far is how to use Terraform to manage things, and then out of a project with, I believe it was with a student, Felix-Antoine had this idea of using a kind of a web-based tool to do this for you. So as a on top of Terraform, to make it a lot easier for people who are not familiar with Terraform to do these things without making typical mistakes, right? So basically, we go from this plain text file to a GUI environment, right? And also it tells you things, right? So it can tell you, for example, what image types are available to you, how much RAM you can actually request based on what quota is available to you, how many cores, which in turn means how many instances that you might be allowed to have. But these are all reflected, right? So for example, things like the floating IP, if you are allowed to actually create one or use one or not, that these are things that can be checked inside with the GUI that you have to know or investigate if you're using the text file. So for MC Hub, you just need the browser and you need an account. You make the configuration. All of these entries look a bit familiar to you, right? So these are the name of the cluster, like the file we edited before, the image that you can list down available ones. There's a big caveat with MC Hub, and that is that for right now, it only works for OpenStack systems, right? So it doesn't work for every provider. So this is only based because the main reason is because MC Hub is intended for the Compute Canada use case, and the cluster, the cloud environment that they provide is OpenStack based. So there's not much, there's no good reason for them to spend too much effort on MC Hub when their use case is already covered once they cover OpenStack. But it could easily be extended for other providers, or easily, I don't know, but it can be extended.
Right. That's where the community will step up.
Yeah, and so then but the useful thing is that rather than make mistakes about quota and things like this, is that these things can be checked. So you can be made aware of what is available to you, and so you don't make mistakes as regarding asking for too much. So for example, I could have asked for spot nodes on the AWS instance that we had, but it wouldn't have worked, right? Because in the region that I chose, I don't have any spot quota. So I could have done it, and it would have almost succeeded, and then complained that I actually don't have quota in the region for spot instances. So if you're using a tool like MC Hub, you can avoid these kinds of issues, right? So, and they're a little bit, once you see them, they're hard to figure out exactly what they are until you become a bit more familiar with using cloud environments. The same thing with OpenStack, and so it's able to, for example, to query about floating IPs. So you need a floating IP, and if you don't have one, you won't be able to configure a floating IP, which means that you won't have a fixed address to address the system, and that's not great. Excuse me. And then once you've configured that form, you can set it off, and it'll tell you the build confirmation. You can say yes or no then to that build, and then it will tell you that it's running things, that things have succeeded, and then potentially where there are problems as well. So on Magic Castle, you have to go off and verify your quotas manually, but in MC Hub, you don't need to do that. You can actually just look at pie charts. That's much better, obviously. In Magic Castle, you'd have to have a configuration file, whereas MC Hub, you just use the web form. For Magic Castle, you read the documentation, but you would need to do that an awful lot less in MC Hub because it can guide you through doing the process correctly. So there are different views. There's the user view and the administrator view. So a user just only sees the things that are related to them, but an administrator can see all of the different clusters that are related for everybody who has access to the credentials. And then, well, that's just a little bit more about MC Hub. It's just that it's Vue.js front end and then something else in the back. You can run it through a Docker container, and then if you want to do authentication for it, you can do it through the Ansible playbook. So I think that is the end, more or less. Magic Castle is a mature project primarily because it's used so heavily by Compute Canada. So they use it so actively, right, that it's kept up to date. And then as more people use it, you get, fixes probably a lot faster. Issues are raised quicker. And it does replicate that HPC environment. Once MC Hub is deployed, it can make that whole process a bit easier, particularly for people who wouldn't be familiar with something like Terraform and don't really want to get familiar with it. Future stuff that hopefully are coming is OFED, so fast interconnects. Actually, we already have that. So for Azure and for AWS in particular, we support EFA. For Azure, I have got the InfiniBand working, but there is a couple of small changes that are required in Magic Castle, and I have a PR open for those to make it work properly with Azure. Felix-Antoine also wanted to look into providing a Lustre file system instead of NFS. The other thing that's not there right now is compute instances that they would automatically scale based on how much are required. That in principle we have, that's technically possible. So one of the big things that Magic Castle is worried about is security. And so auto scaling of compute instances has the implication that you have credentials within your Slurm cluster. Now, if you consider the thing to be not secure in general, then this is a problem. And so we were trying to figure out a way around having to provide the credentials within the cluster. And that's something I think we have an approach to now. So that is in the works. I mean, we have an idea that works in principle, but we're still tweaking that. And then the other thing would be to support an external identity provider as well. So that's the end of the presentation. Let's go back a little bit. See how things are. That did not error. Oh, that's an old one. Okay, let's see how things are doing on our management node. So at this point, we're onto Slurm. Yeah, Slurm is almost finished. It's IPA, so let's see. I think maybe Slurm is now working here. Let's have a look. Simple. No, not yet. It's not fully finished yet. Okay, we're getting there though. So this is usually what I do when I'm waiting for things. Unfortunately, we're running out of time, right? We're already 10 minutes over. So I could let this finish and it will be ready soon, but it will take another 10 minutes again before, or a few minutes more before what was this going to say? So before the compute nodes are also configured. So they won't even start configuring until the management node is done. So we probably won't get there. Okay. What I can do is show you an environment that I already have. This one. Let me show you what Moki looks like, just so you can see if you haven't seen it before. So here's what Moki would look like. So this is the sign-in page. That's my account. It's in there already. You can create the account here. We could do that. And basically just give basic information and press a sign up. If we look at the IPA, I never used that one. So down here, so this is the IPA. So this is what the management interface looks like for the accounts. You can see this one already has a lot of users inside. But basically, if we go back to the Jupyter Hub, oh, it's already logged in. I must have already done that. We can do things here. I actually do have a GPU available on this system as well. We're not going to look too much into it, but we can start that environment. It will tell me that it's running the cluster job, but it's just waiting for a second for it to connect. There we go. And now we have our Jupyter Lab environment. We have all these software modules that we could potentially load. So for example, we can do one. Well, first we look at the terminal here. Just a terminal, we do module avail. There's lots of different software here. So there's a software that comes from Easy, which is under this path. And then there's, in this particular cluster, I've already done a lot of installations because I was trying out different things. So that's all the different software that I've installed in here myself. So built on top of Easy. And then one thing I wanted to show you would be our studio. So let's see, where are you, our studio? Well, let's do this. There we go. There we go. So our studio is loaded, and then if we go back to here and click on this, we get dumped into an RStudio session as well. So you can use RStudio through here. Potentially, you could also use the desktop environment, and that's not configured for Easy though. So that would work with ComputeCanda, but doesn't work right now with us. It's something I have to fix. But that's basically it. And of course, obviously, with that account, I could also just log on to the system via SSH as well. And I have already uploaded, for example, my SSH key, so that would work directly too. That is it. We can go and have a look here and see. I think, yeah, here we go. We can see the message, applied the catalogs. So now the management node is finished. So if we log on there, we'll see sinfo. Oh, node 1 is already almost up, right? So let's log out and log in 1 as well. So we can see if he is probably compared. He is actually, so manager, so login, the login node is ready. The node 1 is almost ready. That would increase to 2 nodes in the very near future, I suspect, so in about 4 or 5 minutes time. But I think that's enough for now. So basically, the last thing I will do here is kill that. So let's kill that system completely. So I can just do wipe everything away with Terraform, destroy. So now everything that I did here will just get wiped away, and so there'll be no resources left.
Yeah, I was going to ask about that, because the classic would be to spin it up and then forget, right, and then get a $1 zillion bill at the end of the month. Yeah. So one of the nice things about MC Hub that I didn't say is that you can put a time limit on the clusters. Nice.
So you can automatically trigger a Terraform destroy after a period of time, which is obviously a big plus for exactly the reason that you say. Now in OpenStack, well, maybe you're not exactly paying for things, but you get the point.
Yeah, well, one way or another, you are.
Yeah. Okay, it's going to tell me all the things that it's going to destroy now, which is everything. You can see here that the usernames, they had a different username. So there was user accounts that would work here with this password, right? That you could share, for example, for a workshop, rather than have people create accounts. Personally, I prefer to have them create accounts. But now that destroy will probably take a while, because sometimes it can take AWS a while to destroy things. But it will start now in a second. Well, maybe we'll just wait until it starts and then we'll finish there. Yeah, so it's starting to kill things already, right? So a lot of things are being destroyed. And I think that's probably enough to give you a quick introduction. Took a little bit longer, sorry, than I expected.
No, that's fine. That was great. I think I learned some things.
And then you also, that shell session was still it should be around for, I think, for 24 hours. So you should, if you want, you can go look through that as well. Okay, so let me stop my share.
So there's a little bit more traffic in the chat from Vincent about I think SE Linux and Oracle, whether anyone's tried Oracle Linux. I'm not sure if that's directed at me or you. I haven't. I mean, I guess it's maybe topical to the SE Linux context. I haven't tried Oracle Linux. We're a Debian shop for now.
So I don't know. I know that was a lot of me talking, right? So
round of applause for Alan.
Yeah, definitely.
But I don't know if you have any more general questions or specific questions even.
hearing none, I'm going to turn off the recording.
Sounds good.
It's a lot of content.